Fluid is a substance that deforms continuously when acted on by a shearing force. Solids may deform when acted on by a shearing force, but they will not deform continuously. On the other hand, liquids and gases deform continuously and are classified as fluid. It is obvious that different fluids can have grossly different characteristics. For example, both water and honey are fluid. However, they behave quite differently while flowing. This behavior can be described by a fluid property called viscosity. Fluids in motion can be thought of having different layers. Each layer have a different velocity with respect to the other. This develops a frictional force between them. Viscosity quantifies this internal friction force between adjacent layers of fluid that are in relative motion. Consider a hypothetical experiment in which a material is placed between two very wide parallel plates separated by a distance h along y-axis. The bottom plate is rigidly fixed, but the upper plate is free to move. When the force P applied to the upper plate, it would displace to a new position AB dash. To resist the applied force, a shearing stress will be developed between layers of the material. The layer closest to the moving plate will stick to the plate such that the velocity of the topmost layer is equal to the velocity of wall. The fluid layer closest to the stationary plate will have zero velocity. This condition that the fluid sticks to the wall and have zero velocity is very important in fluid mechanics and is called no-slip condition. The velocity profile can be defined with this linear equation such that when the vertical distance y is 0, the velocity is 0. When y is maximum and equal to b, the velocity is maximum. A continuation of this experiment reveals that the shearing force P is directly proportional to the velocity gradient. The constant of proportionality is called viscosity.